Let's now re-examine the same problem with the brothers, but in a slightly different way. I want to look at this as a group of equations that we're trying to work with, because that's going to help us solve other types of problems in the future. So it's the same information from the previous example, but now I want to define some variables. The question asks for two different things. When will they have the same amount of money? So after how many months? So I'm going to choose a variable to represent that number of months. And then how much will they both have? Well, that's an amount of money. That's something else I don't know. The things that I don't know are the things that get the variable names. So X for one of them and Y for the other. It's easiest often to use X and Y. Let's now think about how Chester and Stanley's money changes over time. For Chester, for example, he starts with $390. And then each month, he adds on to that $390 an extra $20. That means that after 1 month, I want the 20 to have been added on one time. After 2 months, I want the 20 to have been added on 2 times. And after 3 months, I want the 20 to be added on 3 times. So the thing to do is to take my number of months times that $20. This represents his savings added on to the original. Put that all together, and that's the amount of money that he will have saved in total. So just to verify that this works, we already know that after 7 months, he should have saved $530. That's what we saw in the previous example. So if I take this X and put in a 7, I'm going to do that over here off to the side. Just think it through. So $390 plus that $20 for 7 months, that should be $530. Let's check it out. So I'm going to take $390 plus that $20 for 7 months, and yep, sure enough, he ends up with that $530. This again was just a check to make sure this equation does what we want it to. Let's now do the same thing for Stanley. Now Stanley's starting amount is lower. He starts with $180 and is going to add to that $50 for every month to get the amount of money that he ends with. Well, once again, we can check just to make sure this equation works out okay. We already know that after 7 months, he also should end up with $530. Let's make sure that happens. So I'm going to now do his starting 180 plus the $50 for those 7 months, and sure enough, he ends up with $530 as well. Now, if you didn't already know this, that's okay. You should be able to trust that your equation is set up by just making a small table and checking to see that your patterns hold true. When you have a group of equations like this, and you're looking for an answer to the question, what do the variables represent? You are working with a system. So on your toolkit, let's fill in some blanks. A system of equations just means there's a group of them. Typically 2. We had 2 equations, one for Chester, one for Stanley. There could be more, but often just 2. The solution to the system is an ordered pair. So it is a list of 2 numbers. In our example, for the 2 equations we dealt with, the ordered pair was 7, 530, because after 7 months, they had saved $530. And that ordered pair has to solve all of the equations at the same time. To solve an equation means to make the equation true. So let's take a look over here at the example. Now you'll notice I wrote the equation slightly differently. I put the y at the front and the 390 at the back, kind of changing the order of things. That's so it matches the y equals mx plus b format that we're often used to seeing with our linear equations. Now what's not here is a check to make sure that we actually did okay. Now, actually, we did the check already on the previous page, but I want to write it in here anyway. If this really is the solution, then what I should find is, if I put 530 in for the y, and if I put 7 in for the x, then I should get the same number on both sides of the equal sign. Well, we already saw from our calculator that that happens for the first equation, and it also happens for the second equation. So put the 530 in for the y, put the 7 in for the x, and we just want to make sure that we get the same number on both sides. Well, we've already checked it, and we know that we do. This is what it means to solve a system. 7 for the x and 530 for the y is the ordered pair that gets you a true equation for brother number 1 and a true equation for brother number 2. For the rest of this unit, we're going to focus on different methods to solve these systems and how to write the equations ourselves.